Hello everyone, in this video we're going to talk more about graphing absolute value equations. I'll drop a link for the last video I did where we did vertical translations, which remember is where we have the graph of the absolute value of x and then we'll have plus some random number, I'll call it k. It could be the absolute value of x plus some random number, or it could be minus some value. This vertical translation moves the graph up. This translation moves the graph down. Let's now take a look at what if we wanted to move our graph either left or right. Remember that with these translations, the result is a graph of the same shape and size. It's just going to be in a different position. And in this case, it'll be either to the left or the right of where we originally started. So how's this going to look? We'll start with this graph, and then we'll take a look at one where we move to the left, and then one where we move to the right. Here we have our original function of y equals the absolute value of x. Using a different color now, I'm going to take this graph and I'm going to shift it either left or right. But by how much? Let's do the absolute value of x minus 3. So here we're going to have a shift of 3 units to either the left or the right, but how will we know which one? Here's how we know. We plug in any value for x, whether it be positive or negative, and we will get some value above 0. Unless we plug in 0, then we'll still have 0. But if I plug in a value of x that is bigger than 0, try this. If I plug in 1 minus 3, well, that's negative 2. The absolute value of that is positive 2. So now I have the point 1, 2, which is up here. If I were to plug in 0 minus 3, well, that's negative 3. Absolute value of that is positive 3. So now I have 0, positive 3. Let's plug in 3 and see what happens. 3 minus 3 is 0. Absolute value of that is 0. So my graph is down here. This graph is now 3 units shifted to the right. So that bottom point now is no longer at the origin, it's now 3 units this way. All respective values that you get for y are going to be above the origin, or rather will be either on the x-axis, but they will never be below the x-axis. So if you ever have to translate a graph to the right, it's going to be x minus some number, and whatever that some number is how far to the right you're going to go. Again, assuming it's x minus a number. By process of elimination, you can probably guess how we're going to move a graph to the right, or to the left rather. Here we have our original function. Let's take this graph and we're going to move it now to the left. Let's move it 2 units to the left. So let's plug in the 0 value first. So the opposite of positive 2 is negative 2. If I plug in negative 2 and add 2, That's going to give me 0. Absolute value of that is 0. So now my lowest point on this graph is going to be right here. Now every respective value of x I plug in compared to this graph will now be 2 units to the left of where it originally was. So plugging in, let's do 0 next. Plugging in 0 will give me 0 plus 2, which is positive 2. Absolute value of that is positive 2. This is my new point. So everything is now 2 units to the left. And that would be the biggest difference in deciding how a graph goes left versus right. You can individually plug in points and see where it falls on your graph compared to the original one here, and seeing that in this case horizontal shift to the left 2 units. And then recall over here we had that horizontal shift 3 units but to the right. That takes care of vertical and horizontal translations. There are other translations with graphs, but we'll worry about those a little later. Thank you so much for watching, and I will see you later.